Thank you for joining us for Part 7 of our investigation. In the first 6 episodes, we presented evidence for the existence of a thought monopoly in America. In other words, public education, government, and major news companies are spreading a unified message. This message is cloaked in an ideological wrapper consisting of scientism and postmodernism. Their propaganda attempts lend scientific credibility to metaphysical issues. These issues have been called boundary questions. In this episode, we will finish hearing from scholars with varied worldviews, give us their opinions and reasons for their beliefs on the question of origins.
The origin of life research is still in the hypothesis stage, apparently.
Yes.
And in the scientific methodology, that's like the basic, right? And so, according to the report that just came out yesterday, they said that we not only don't know how life began, but we don't know where.
That's right.
And so we're still kind of working hard to try to find that. In fact, there's a competition every year to try to get closer.
Yep.
So what do you think the next step is?
Wow. I think that, the scientists are doing all the right things in the sense that they're trying with the fossil and geological studies to figure out what planet Earth was like back then. So there's all kinds of different hypotheses. There's the clathrates in the ocean, and I don't know, there's the little lipid globules that might have occurred if you got lipids somehow. So people are sort of working on all of that. But I think since we have no idea what sorts of encapsulation systems might have been around 3.5 billion years ago, it's sort of really groping in the dark at this point. The feature of DNA, RNA, and proteins that is unique about them is that they're long polymers, and they're built up from these, small molecule units incrementally. And you don't have anything long enough to make a uniquely folded protein until you have about 300 nucleotides in a row.
Wow.
And, normally they're floating around one by one. So somehow you got to get the monomer concentration high enough and the reactivity high enough that they're going to start making these long polymers. So there's all kinds of ways that we can envision that chemistry might have occurred, but we don't know.
Wow. And a lot of it has to do on what the atmosphere was like on the planet.
Exactly. That's exactly right. That's exactly right.
Most scientists today agree in common ancestry. Would you agree with that?
Oh, absolutely.
Absolutely. So does that mean then that every plant and animal that's alive today came from the same original cell?
Well, we don't know whether life originated more than once on Earth.
I see.
But certainly we do know that all living organisms come from one single origin, from one single cell, if you want to put it that way. If other forms of life originated, they became extinct. So the answer to your question is yes. Every living entity on Earth derives from a single origin.
And how do we know that?
Well, again, studying the genes, we can see the makeup of the genes, and particularly the sequence of genes, the sequence of DNA in the genes, and the sequence of amino acids in proteins. Genes in an organism are like a book.
Right.
Each one of us, humans, we have 6 billion letters of these components. And they are organized in a sequence which carries information. So it's like reading a book.
Right.
So that is as much information as maybe 500 books the size of the Bible.
Wow.
So we have a lot of information. We have as many letters there. To start with, you look at one page in several of these books. Each one is a book. In this case, will not be so much you and I as, say, the chimpanzee and humans. And we find that 99% of the letters are identical and in the same position. You know that those two things have not come about independently, and they must have had a common origin. One letter has changed, but all the other ones, the other 99%, are the same. And of course, in different groups of organisms, different letters will be changing. It's like you are comparing Bibles, in the other ones, you are comparing the works of Shakespeare. But all of them follow, the text, which is identical except for a few letters that change from time to time.
Okay. How did inorganic chemistry, actually become something alive? Can the fossil record shed any light on this question at all?
Afraid I can't tell you.
Okay. Yeah.
It's a question, if it's for anyone, it's for the chemists or the biochemists. We have interesting fossil evidence and molecules that can be found that give us suggestions about when things happened or where they might have happened and what kinds of environments they might have happened. But we don't really have anything that's going to tell us the story of life originating in the same way that we might be able to see the story of when we first got land vertebrates.
Okay.
Besides which, we're not sure that it happened on Earth. Yeah, could have happened elsewhere.
Yeah.
Yeah.
Maybe come here on a meteorite or something, or an asteroid or whatever. Yeah.
After all, about the same time that we see the first fossil life on Earth, the Earth was being bombarded by meteorites. We know this because of the way they impacted the moon, and those scars are still there, unlike on Earth where they've been erased by weather and plate tectonics and so forth. Yeah, so it's always possible that life came from outer space. Yeah. So that makes the problem a lot harder, too.
It sure does, yes.
I'll let you know when I get to Mars.
Okay. This whole concept of the last known ancestor.
Last universal common ancestor.
Common ancestor. Yes.
Yeah.
Luca. Yeah. Does that mean it was an amoeba? Or what are they talking about when they refer to that?
So, in evolutionary theory, the beginning of life, the abiogenesis, the production of life, was thought to occur from biomolecular molecules through natural processes, and that the first sign of life was a self-replicating cell that was very minimalistic, in the sense of if we were to compare that to the complexity of a human cell today, or even the complexity of a bacterial cell today, it would be more simplistic than that. And that's been a theory that's been a part of evolutionary theory for quite some time. And yet, as we've begun to sequence the genomes of many different types of complex animals and many different types of bacteria and many different types of plants and something known as archaea, what we've discovered is that the data from genomic sequences don't actually point back to a single branch point, sort of the tree of life, with Luca being at the very base of the tree. A web is the way I like to think about it.
A web.
As far as the way that the genetic and genomic information relates to one another. And there seems to be 3 nodes, perhaps, in the web. Those 3 nodes would be bacteria, eukaryotes, and archaea.
Okay.
Yeah, so eukaryotes would be the cell that is most similar to the human cell, and animals. Yeast would also be a eukaryotic cell. So although it's been a phrase that's been used and associated highly with evolution, and it is pointed back to as the theoretical common ancestor of every living thing, I would say that that's even in question now based on the genomic data, that there probably isn't one Luca that we can point back to, but there would need to be at least 3, because it's hard to see how those 3 nodes would relate evolutionarily to one another.
Wow, that's fascinating.
So it's very complex, yeah.
So the mitochondrial Eve scenario points back to Africa, is that correct?
It is, and that's actually why most people have abandoned the multi-regional idea of human origins, and most people now, most scientists would say that the out of Africa is the best account for human origins.
And how do they know that?
It's from the mitochondrial analysis. So we actually know that the oldest modern human DNA in existence traces back to Africa.
Okay.
And so we base all of that on genomic data and mitochondrial data today.
Oh, okay. So do we know then if it was Neanderthal or Denisovian or?
It was human, what we would call modern human.
Modern human, okay.
Yes. So the technical term is Homo sapiens sapien, which differentiates us from other Homo sapiens like Neanderthal or Denisovan. So those are actually very distinct from us, both in mitochondrial DNA and in genomic DNA. So
that's good.
different species.
Good to know. Okay. But I think a concept a lot of people had is that species can't interbreed. They can't, and so hybridization occurs and then everything stops or whatever. So that's another point I think a lot of people are unclear about as well. So
right. First of all, it's important to realize that the definition of a species is kind of in flux within the scientific community. The canine species used to not include the wolf, but now the dogs and the wolves are actually considered a similar species. And so the definition of a species and what are the boundaries of a particular species is in flux and difficult to define and delineate. But genomically speaking, by analyzing the genomes or the mitochondrial DNA, we can see that there are distinct differences between the Neanderthal DNA and the Denisovan DNA when compared to each other, and also when compared to the human genome of modern humans and what we would refer to as modern humans in the fossil record. And so some of the fossils that we have access to are fossils of Homo sapiens sapiens. Mm-hmm. Some of the fossils we have access to are Homo sapien neanderthalis, which would be the Neanderthal fossils. So the DNA sequences, statistically speaking, as we do those comparisons, it falls out of the statistic bound to be just variation within the modern human genome. And so it's recognized as a separate entity.
Okay. Thank you for that.
Sure.
That's good.
I guess most people don't know it, but we're made of star stuff. Every atom in our body was forged in the center of a star, and then it either went nova or went to the red giant phase and blew off its atmosphere. Every bit of us, everything in this room, excepting some of the hydrogen, which was primordial, but every iron atom, every calcium atom, every sodium atom in our body was formed in a star. We are intrinsically part of the universe. We go out and we look at this universe. We are part of it. We are not just little people like ants running around the surface of the Earth. The Earth is a planet. We have 7 other planets in this solar system. We've discovered something like 2,000 extraterrestrial planets now by various means. We are part of this immense story of the universe, which began 3.7 billion years ago with the Big Bang, and that has evolved to give us what we have, and will continue to evolve. And so you've got this majestic, magic event, which we are part of. And when you stop and think about it, if it weren't for stars, we wouldn't be here. Not just because we need the sun to give us energy, but our very bodies were part of a star. And the solar system was formed 4.5 billion years ago. So maybe 5 billion years ago or 6 billion years ago, these atoms were in a star, and they were distributed by these events in the universe, forming clouds of dust and gas, and then it condensed into our solar system, our planet, and here we are. Mm-hmm.
This is the Origin of Life project with our annual review report. Scientists still report not only do we not know the how, we also do not know the where of life, or how it began.
Mm-hmm. So I think if you press people that are in the origin of life research community, the surface of the topic, I think, is littered with all sorts of personal worldview impositions. Chemical forces aren't what bring DNA together. There's no bond force that's pulling them together. It's molecular machines that are programmed to do particular functions that fold the amino acids and all that jazz. So chemical evolution, as I recall, technically died in the late 70s, but it stayed in the textbooks even till today. People like Richard Dawkins, they're still banging that drum, and people are still falling for that belief that just if you put all the stuff in the soup, eventually something meaningful is going to pop out of that. When a scientist speaks words, the average Joe out there is not using those words the way we use them. And so there's connotations that are perfectly natural and fine, but they're different. Randomness doesn't mean what it's often ascribed to mean, especially by the antithesis of that world, which would be, say, a creationist viewpoint. By random, they don't mean roll the dice, chance randomness. A lot of the arguments against origin of life by means of evolution or chemical evolution, which I actually think died in the 70s, but it's not that. But then there's this leap where we go from, well, it's not a roll of the dice, it's not random chance and forces, and there just is certain natural selection in there or something just magically does the rest of the work. And I think that's wrong. The natural selection is not capable of bringing non-life into being. Natural selection works great once living things are here. So you have to have an organism, and then natural selection can do stuff. And I'm of the belief, based on what I've learned about genetics, that if I knew enough about a genome, if I knew how to flip all the switches, I could turn a frog into a dog. I don't think any human will ever obtain that much knowledge, but it appears that the capacity of genetics is in that ballpark. But making that happen over any time frame less than the current age of the universe versus what its ultimate maximum age could be, according to the laws of physics, that's not enough time. I think we do an awful job as scientists and educators in this system in communicating what the ideas really are, what the facts are, what the fiction is, where the philosophy spills over or not. It's a mess. I think it's an absolute mess.
So there's initial causes, which is a big realm, of course, for the potential of an external agent that's not scientific. The other realm, of course, which is the other field, the life sciences, is the nature of pattern and complexity and the presence of humans and our role in the universe and whether we're special or not. And I'm not, that's not my discipline, but I have pretty strong opinions about that, of course, because I followed the research pretty well. And I certainly know that even though we haven't told the story in detail of how life started on Earth from simple chemicals, and you get cells, and then you get us, and it all takes 4 billion years, and we've painted large parts of that picture. So no supernatural agent or intelligent designer or magician working levers of a machine that we don't understand is required for that story either. So and that's the other area, of course, where there's a cultural issue which comes into play of a set of people who look at the complexity of the world or the operation of a single cell and just say that's too amazing to have happened by unguided forces. And that's scientists who work in that field will strongly refute that notion.
Yes.
And have done.
Yeah. Well, it is on our agenda to interview some microbiologists, paleontologists and so forth, to go down those areas so they can speak directly to their own science. So that should be interesting. Should be some interesting conversation.
But I mean, I like, as a scientist, I'm trained in one discipline, but I would be poorly educated if I were not able to describe the gist of other forms of science. Yeah. If I believe that I have a rational view of the world, you're talking about rational worldview, and somebody comes up to me in the street and they don't know I'm a cosmologist or whatever, and they say, well, it's impossible, this evolution thing, it just doesn't work, because how can you get an eye, or how could you get a cell, or, and then they just look bewildered.
Right.
And, that is a big door that I will walk through any day.
Well, I think the sticking point for a lot of folks that are in that belief system is the mathematics that underlies all of that. Because according to most scientists I've ever talked to, given enough time, anything can happen. And so I think for a lot of people, that concept is like, well, that's just an answer that you're giving me. I don't know that you can prove that to me. You know, it's that sort of a mindset, I think, that is a sticking point for a lot of people. Given enough time and enough different mutations, then anything can happen.
Right.
And so that is like me trying to understand what billions of years is. I mean, it's hard enough for me to understand what thousands of years are, let alone thousands of thousands and, you know, millions of thousands. So I think that, and correct me if I'm wrong, but I think that's where a lot of people come from on this lack of belief or confidence in science over their innate primitive ideas of the way things are.
I think that's part of it, but I actually think it's not sufficient to explain a lot of people's reaction, because the idea that with the multiplicity of matter in the universe and vast tracts of time and interactions happening all the time, anything can happen, is a component of the situation. But often what they're reacting to is something different. It's not that anything can happen, it's that this thing happened. This very specific thing happened. And if you look at it, you know, a single cell, like the amazing chemical factory that is a simple cell with its incredibly organized components and its DNA and its RNA and its coding and proteins and so on. Just like crazy complicated, but it's very specific. It does a particular thing. It's a machine. Right. And so people make that analogy. You know, it's the classic
irreducible complexity.
It's it's the watch found on the roadside. These are bad analogies, and they've been deconstructed many times. But the reaction of someone not familiar with the science towards that reaction is understandable. It's understandable. I'm not a biologist, and it's amazing to me when I get to see what's going on that cellular scale. So I think it's not that anything can happen. It's that this specific set of things happened, and it looks so, you know, it's so created and amazing and complex and purposeful to our end. It's teleology. So people will incline to the teleological viewpoint for that reason, and it's understandable.
Sometimes scientific terms mean something different to a scientist than they do to a normal person. So when we speak about causation and the beginning of the universe or the Big Bang or any of those big, you know, ticket items, where does causation play into that?
Very interesting. And I want to distinguish between the question of what does it mean for something to be caused and what is the scope of causation? What sorts of things can be caused or are caused? And I think as far as the meaning goes, I think it helps just to start with examples. You light the gasoline and a fire starts. And so by that example, it looks like we can understand a causal connection between one event and a resulting event. And so I think this is, you know, how scientists think of causation as a connection between events. One event causes and produces another event. But then there's this other question is, what kinds of things are caused? And this is really interesting because I think one of the guiding principles of science is this investigation of causes. You know, this is sort of the underlying principle of all science, is looking for causes, looking for explanations. And so philosophers then are interested in, well, what's a kind of a grand causal principle that can account for all of our data of causation? Every scientific experiment involves some kind of causal connection from one event to another. What's a grand causal principle? And I think a very simple principle that accounts for the data, and I take this to be the most plausible principle, is that every event whatsoever is going to have some kind of a cause. And even more generally, any entity that exists, but that doesn't exist of necessity, its non-existence is a real possibility. It could be gone from reality, it could be absent. It's something that's going to have a cause, something that brings it into existence, that explains its existence. And one reason I think this is because I don't think that, you know, take this cup, for example. Something caused it to exist. This table, something caused it to exist. What's the difference between the table and the cup? Well, not a relevant difference when it comes to causation. They differ in shape, right? Well, now we can talk about the universe as a whole. It's different with respect to the cup and the table in that it's bigger. It's got a different shape. It's got more parts. But I don't see how this difference in shape is relevant to a difference with respect to having a cause. So it seems to me that if tables and chairs and electrons and these sorts of things have causes, then the universe itself would also have a cause, because it's not relevantly different from the other kinds of things that have a cause. So I would think then that the universe as a whole has a cause of its existence, unless the universe exists of necessity, unless it's an eternal, necessarily existing thing. My understanding from contemporary science is that that's unlikely. The universe probably had a beginning to its existence, does not exist of necessity, so probably has a cause of its existence.
Right. Very interesting.
According to current scientific evidence, we still don't know what caused chemical elements to become living cells. Speculations are based upon personal worldviews because no scientific proof exists yet. So what will our scholars say when asked about morality and ethics?
At this point, we have witnessed how our scholars support his or her scientific knowledge based on acceptable authorities and their own personal experiences. However, their reason and logic is based primarily on their individual perceptions of reality. In other words, they are relying on philosophical and/or theological foundations to explain the origin of life, the cause of our universe, and human exceptionalism. Yet, scientific naturalism is the only acceptable worldview that can be taught in public schools, upheld in our courts, and reinforced by the mainstream media. This thought monopoly has virtually eliminated theology and philosophy from the realm of public discourse. Therefore, most citizens in the U.S. today are perplexed by the question, how do you know what you claim to know? If we cannot evaluate evidence based on a logical framework, then how can we pretend to make ethical judgments on legal matters, especially matters resulting in human behavior? I'm John Jones. Join us next time as we examine this conundrum.
For more information, email us at thoughtmonopoly@gmail.com.